So we need to go over all of these limit laws. There are multiple, as you can see, they're not that bad. But what you're doing is when you have two different functions and you're going to take a limit of each function, and they're already defining it for you. Look up here. The limit as x approaches a of f of x is L, and then the limit as x approaches a of g of x is M. What happens if I were to then add and take the limit of f of x and g of x? Well, exactly, but the way you write it is the limit of as x approaches a of f of x plus the limit as x approaches a of g of x. It's, I don't want to say it like this, but this is how you can remember. It's like distribution of the limit word. But then obviously if this is what, this right here is equal to L, and then this right here is equal to M. So you are allowed to add, as long as it's all going to the same x value, you are allowed to just add the limits together. So then what do you think the difference law for limits would then look like?
The same thing except for subtraction.
Same thing except for subtraction. Okay, and then you would just have L minus M. Now this one is neat. When you have a constant C inside of a limit, so if there was like a 2 or a 3, you are allowed to, by law, take that C out and then take the limit as x approaches a of f of x. And again, we know what this limit is. This limit, they already told us up here, is equal to L. So this would just be C times L. So if it was like a 2, it'd be 2 times whatever the limit is.
Why are there so many laws?
There's laws for everything in math.
You have to have.
Same thing with product. You can just multiply by the limit of each. Multiply by the limit of each one. And so this would be L times M. And then quotient, again, you can actually, I don't want to, again, say the word distribute, but you can think of it like that. You just take whatever limit's on the outside and take the limit on the top and take the limit on the bottom. This becomes into play, especially for those of you who are going to take like an engineering calculus next year, okay? You need to know how to separate your limits. This 2 right here is an accident. This is a typo. Call this n, because I just want to make it like some n variable. So if you have a function raised to a power, you can actually, again, take the limit of what's inside and then raise that to the power. So you could write it like this: the limit as x approaches a of the function, and then raise that to the n power. So this would be L to the n power. Now what would you think that would be for then the root law? Same thing. So it would be take the limit. The whole idea, listen, this is the whole idea of all these properties, is that you take the limit of what's inside and then do the algebra part or do the operational part after it, okay? Now, I'm going to show you how this applies to a problem that you'll see on a test and you'll see very soon.
Is it just n root of L?
Yes, I'm sorry, I didn't write that down, thank you. The nth root of L. Okay, now, so for example, this one. Given that the limit of x approaches 2 of the function f of x is 2, the limit as x approaches 2 of the function g of x is negative 4, and then you have another function, the limit as x approaches 2 of h of x is 5. So listen, all of these have to go to the same. All of these have to go to x minus, it goes to 2. It can't just go to 3, okay? So what do you think I would do with this problem then? You're just going to add them. It's exactly what it is. That's what all of these are saying. You just, now let me write this out the long way though, for those of you who have to take like engineering calculus. You would actually take this 2 and take it on the outside. And then you would, again, hate to say the word distribute, but distribute as limit as x approaches 2 of the f of x, and then the limit as x approaches 2 of the g of x. And again, this, I know what this limit is. That's up here. Right here, they told me that the limit as x approaches 2 is 2. And they told me this one, that the limit as x approaches 2 of g of x is negative 4. And then multiply that by 2 and do your order of operations. What would you get? Negative 4 is the limit of that function right there. That's exactly it. So what would make this easier than me writing all this out? What would make this one easier? What do you think? Plugging it in. So if I have something like this and they're already telling me the limit as x goes to 2, this one is also the limit as x goes to 2. Couldn't I just take, well, h of x is 5. Minus g of x is plus 4 over, and then take the cube root of it. And and leave your answer, by the way, in an exact form. Cube root of 9 over 2. And so this is the first rule you're going to do in your notes. Put this away. You're going to take out your notes right now. We are to do 9 problems together. You waste my time, I will waste your time. I'm in no mood, children. I've had 4 periods. Don't even. You all sit there and you all didn't let me know. You just let them sit back there with the clock.
I didn't even know they took.
I know.
That was really funny.
They thought it was funny and they were going to write a letter
What
saying,
lesson is this?
Same lesson.
Oh, wait, Andy was actually the ringleader in taking the clock. She told us to do it.
Yeah, because I'm so 2.1.
Actually, I'll take a sidebar.
Silly message.
I thought for a second, if they take my phone, I will kill them.
Thanks for the
I'm not that creative.
Can be locked out of that book.
I'm like, oh, there would be a write-up to the 10th degree of that one, because I'm like, I'll kill them.
Ask Taylor about it.
Oh, I know. That's why I was like, oh, I'll kill.
No.
Mrs. Sutter, you know what you do now? Take their apples. Oh my gosh, can you take their apples?
Take their apples.
No,
Give them to me.
that's not regulated by the government.
All right. Here's the first 3 questions. Again, we got 9 to do, so we got to go quick. The limit as x approaches 4 of, here's a function, the limit as x approaches negative 2. What you're supposed to do, and again, depending on what teacher you have, you would have to write the limit as x approaches 4 of x squared, the limit as x approaches of this one, and then you'd have to pull out all the functions, I'm telling you, and we're not going to do that. Because if you notice, all you have to do is something called direct substitution. The first thing you're going to do is just plug it in. Always. For every limit on homework tonight and on which homework you get, plug in this number. So 4 squared minus 6 times 4 plus 3. Negative 5 is the answer. On all of the limit homework problems, the first thing you're going to do is plug it in. Okay? So then what would this one be here?
So negative 8 times 4 is negative 32 plus 1 is negative
1 divided by 5.
Negative 31 divided by
Negative 31 divided by 3. Yep, leave it like that. Don't rename it. Don't give me a decimal. Leave it exact. How about this one? This one's even easier. Square root of 5. Leave it like that. Okay? This is the first rule of limits. Plug it in. Plug the x value in and you will get out the limit. Plug the x value in, you get out the limit. Can you understand that first? On all of homework tonight, you need to do that. Now, obviously, sometimes it's not going to work. And I'm going to show you 2 right now where it doesn't work, so we have to do something else. The limit as x approaches negative 4 of x squared minus x minus 20 over x plus 4, and then I'll write another one. X minus 3 over x cubed minus 3x squared minus 7x.
like when there's like a hole in the graph or something.
Something like that. Mm-hmm.
A lot.
So the biggest part of homework and actually of calculus is just if you know your algebra, you probably already know what to do with calculus, honestly. Like, if you took this problem right now, there's probably a little guy inside of you, or girl, or somebody, that says, I don't want to say it. Okay, that says, oh, that really looks like something that I want to factor. But before we do that, okay, just to show you something, if you do your first rule of limits, which is to plug it in, you would get 16 plus 4, which is 20 minus 20, which is 0 on top. Is 0 on top allowed?
Yes.
Yeah.
You are, okay?
Okay.
But negative 4 plus 4 is 0 on the bottom. This, many students say is, oh, D and E, we're done. No.
Just 0.
No.
It's 1.
Because it's the.
Write this down.
It's 1. 0 divided by 0
This is called an indeterminate form. You cannot divide by 0, and anything, I know we're like, oh, well, anything divided by itself, you just can't divide by 0. So in mathematics, this is known as an indeterminate form, meaning you can't just say, oh, I've determined the answer is 0, or I've determined the answer is D and E. If you get this, you can't just stop. You have to do something else, and that something else is usually algebra. So what do we want to do this top right here?
Factor out.
And what do I get?
X minus 5, X plus 4.
Okay. What happens then is these will cancel, and you will be left with a new function that you are now going to take the limit as x approaches -4 of. And if you plug -4 in, what do you get right now? -9 is the actual limit. And again, that's because if you looked at this graph, you know this, there's a hole in the graph at -5. There's a hole right there, and it still has a limit. So, hint, 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 I'm going to tell you right now, this one's going to also be 0 over 0. I'd like you to factor. Do you know how to factor a 4?
Yeah, you
Yeah, you put it in.
Grouping.
Group it. Good. Go ahead. Go group.
Go group.
What, x squared and then a -7? Or just 7?
Yeah, I would pull out a -7. Yeah. Okay. And then rename this to be x minus 3 times x squared minus 7. Now what can cancel from top to bottom? Now here's the problem that many students get wrong again. Listen, it's 1 on top, not 0. 1 over, the only thing I now have on the bottom is x squared minus 7. Now you can take the limit as x goes to 3. Plug 3 in, you get 1 over 9 minus 7, which is 1/2. Okay? So the second rule of limit laws, write this down, is to factor. Factor. Factor after you directly substitute it in. Factor. Okay? But there's still obviously more because I have 9 problems to show you.
It's fun.
I'm loving it.
It's not hard. It's just all the algebra that you finally, that you finally used is coming to play.
What row?
Oh, right.
I think Sandberg's my favorite.
Okay, so the limit as x approaches 9 of the square root of x minus 3 over x minus 9. And then the second one, very similar. Square root of x goes to 0 of 16 plus x, sorry, limit as x approaches 0 of 16 plus x square root minus 4 over x. Okay, now, if you were to plug in 9 again, listen, you would get square root of 9 minus 3, which is 0 on top, which is always okay. You can get 0 on top. But 9 minus 9 is what? 0 on the bottom. And you can't just say, oh, then it's D and E, it's not determined. No.
It's indeterminate form.
You have to do something else. Well, there's nothing to factor, but go back in your algebra with me. What did we ever do with square roots?
Square. No, multiply.
Oh, the
square root of x
grade
plus
one.
the
I'm wrong.
conjugate.
I'm wrong.
Plus minus.
I don't.
Conjugates. Okay, now, what's the point of conjugates? Let me remind you. The point of conjugates was usually, back in algebra, to get the square root out of the bottom, or out, that's what we would do. But it's already out of the bottom, but it still helps us manipulate it. So watch. Wherever the square root is, and whatever it is, multiply by the conjugate. I know it seems weird, but it will help us. And whatever you do to the top, you have to do to the bottom. So what is the conjugate of the square root of x minus 3?
Root of x plus 3.
Okay, do the same to the bottom. Now watch. Remember with conjugates, you don't actually have to FOIL it out. You just have to FLA, because the first time's first and last time's last. The middles will cancel. Square root of x times square root of x is just x, yes? Negative 3 times positive 3 is? Oh, interesting. Don't I already have an x minus 9 on the bottom? And a square root of x plus 3 is still down there.
1 over x plus 3.
And then it will cancel. You'll be left with 1 over the square root of x plus 3 that you can now take the limit as x approaches 9. And
1/6.
1/6 is the answer. That is the limit. Do number 7 right now then. Same way. multiply by the conjugate. Don't cancel anything, don't FOIL anything, just multiply by the conjugate and see if something cancels. And again, whenever you deal with conjugates, you just have to first times first, last times last. So if the square root of 16 plus x times the square root of 16 plus x pops out and just becomes 16 plus x. But the negative 4 times the positive 4 is what? Minus 16.
So those cancel out.
And so you have x on top, but you still have this x on the bottom.
So you just cancel it out.
And it's going to cancel with the x on top. Good job. And please, please don't forget you have now a 1 on top. Right? If everything cancels on top, you have a 1. Never a 0. 16, square root of 16 plus x plus 4, and now you can take the limit as x approaches 0. Put like a 0 there.
Oh, so it's 1/8.
So it's 1 over the square root of 16 plus 4, which is just 1, not fourth, 1 what?
1/8.
1/8.
Oh, yeah.
Okay, now, that's the next thing I want you to write here on the side, though. Write this on the side. Conjugate. This is how you always deal with limits. You go from direct substitution, factor. If there's radicals, you do conjugates, okay? All right? Last two problems, flip it over. We're done.
What was the second set?
Is this
On this? It's still part of 2.1b, whatever it was.
Factor?
Factor, this one. Yep, direct substitution, factor, conjugate. And then the last one, I will just do, we're going to do two different, this is 8, whoops. The limit as x approaches 1 of 1 over x plus 1 minus 1/2 over x minus 1.
Whoa. Oh, I remember doing this. I hated it.
Okay.
Oh, cool. Thanks,
Not
Simon.
take math now.
Big log.
Oh.
Uh-oh.
You have to write this. I'll give you a minute. Mm-hmm. It's your last two. You can do it. You can do it.
I don't have enough space.
You can do this.
Oh, no.
Thank you for the bit.
All right, baby. Beautiful name.
This is where I usually clock out.
Don't clock out. This is good. We're done. We're almost done.
Don't clock out.
Don't clock out.
What did he just say?
That's
Your clock.
Clock.
You're so
It
done.
would be so unfortunate if
You
your
are
phone goes
so
missing.
done.
How is Clock Valley gonna go missing?
She's not missing that. Just not taking this photo.
All right.
Don't hurt.
We'll start with number 8 first. Okay? What, just right now, by the way, if you plug 1 in, you can already see, isn't there going to be a 0 on the bottom? Okay. So right now, algebraically, think with me, what don't you like about this? Okay, so what would you want to do then?
Get rid of the fraction.
Make it 1 fraction, which is what you're saying, pretty much. Okay, so here's what we're going to do, and for those who don't remember how to find common denominator and all that fun stuff, I'm going to just make this 1 fraction and then make the whole thing 1 fraction, okay? So the common denominator between an x plus 1 and a 2 is just that, 2x plus 1, right? We've done this before, especially when we did trig and all that. And then do you remember doing the crisscross method? That's how I do it. 1 times 2, you always start from the left though. 1 times 2 is 2 minus, because this is going to distribute into here,
X minus.
minus x minus 1. Did I lose anybody on that one? Okay. Clean that top up for me. What would that become?
Negative
1 minus
1 minus x. I'm going to write it like that. Okay. 2 over x plus 1. Now, this is still all over, yes, x minus 1.
Does not cancel.
Okay? X minus 1 over 1. Can't cancel it yet, but yes, they're going to. You can write it like this if you want to. Did you know that this can almost be written like x minus 1 if you factored out a negative? So if I factored out a negative 1, I would have x minus 1. So watch again what's happening here. Look at this top. I'm now going to rename it, just that top. I'm going to call it negative 1 x minus 1 over 2 times x plus 1. Did I lose anybody there? That's this right here is that right there. Okay? And then whenever I divide by another fraction, we say what? Keep, change. What would this flip be then?
1 over x minus
1 over x minus 1. Do you see that something will cancel now? Wouldn't this and this cancel? You need things to cancel if you're doing limits right. So then what would be my new one fraction of this whole thing? Negative 1 over 2 times x plus 1. Now I want you to take this limit as x goes to 1 and tell me what my answer would be.
So it'd be negative 1.
Okay, so I can see some people are lost, so I'll take the process again. Ready? If you got it, just sit there for a minute. I know, but I'm just saying some people didn't, because some people's jaws are open and eyes are big. I get it. Okay?
That wasn't me, I was saying.
Oh, yeah, you. Okay? Your job is to... I'm covering it up, because if you got this, it's fine. Okay? Look. My first job was to just get that to be one fraction, yes?
Yeah.
And the common denominator of those two. Did you follow along with that? Okay? So I just was like, okay, I'm like 2 times x plus 1, crisscross to negative 1 distribute, yes?
Oh.
And that simplifies to be on top 1 minus x over that, correct? Well, I kind of was looking at the bottom and I was like, wait a second, that 1 minus x, that x minus 1, I can almost get them to be the same. I'm just going to factor out a negative 1. If I factor out a negative 1 from this top right there, just from that top, is it negative 1 times x minus 1? Isn't it going to make 1 minus x? Okay, so instead of me writing 1 minus x over this, I'm going to write it as negative 1. That's what I did right here. Negative 1 times x minus 1. This pink right here is that pink right there. I just transposed it. Okay? And then whenever I divide, I keep change, flip. I got to flip that. Flip. 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 Flip.
So, why is there a paper there in the way?
Okay.
It's all right.
Cross it off, and then you get your final answer and plug your n in. All right?
1 over 4. Negative 1.
It's negative 1/4. All right.
Where'd you get the 2 minus x
I got all
minus
work.
1 from?
2 up here, because 1 times 2 is 2. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. And then I just clean that up. 2 and a negative 1 make 1, negative x. Just clean it up. All right. If you don't get it, you're going to have to practice it anyway and then come and ask me. Last one. What do I do if there's a piecewise function? Okay? Piecewise functions are actually really easy if you understand. They go into pieces, okay? So, once again, listen to me. If you see this symbol right there, that is coming from the left, which is less than 2 or greater than 2.
Less than 2.
So the top, we would plug 2 into the top. What's 4 times 2 minus 3? That's the limit on the left. Done.
5.
So then if this is plus, would I be less than 2 or greater than 2?
Wait, hold on.
Greater. So greater has to be the one on the bottom.
Well, yes.
So plug 2 in. 2 minus 3 over 2 squared, is 1. Question though, are those the same limits from the left and right? So this one would be D and E.
Hooray.
And that is it. Okay. Well, then you're going to get in trouble with me and not be on my good side.